Hey guys, welcome back. Today we're going to start some new note sessions, carrying on what we did last session. Last time we covered bonding. This time we're going to add on two different types of bonding and how the periodic table, the placement of an element on a periodic table, determines how an element will bond with another element. So let's get started. All right, so as you can see, I have my notes here. For our notes, we're going to be covering types of bonding, covalent, specifically covalent and ionic bonding. We have a essential question. How does the placement of an element in the periodic table determine the type of bonding it exhibits with another element? So I'm also going to have my periodic table here. Bring it up so you can see. So yes, I know my periodic table is a little messy. I wanted you to see. So if we look at our periodic table, our table is split up in two different sections. Everything in orange we classify as a metal, whether it be a straight metal like lithium through francium. Beryllium is an alkali metal all the way to radium. Then we have our transition metals throughout the middle, as well as these down here. So these metals have very similar characteristics. Then if you step over to hydrogen, who's up here all by his lonesome, he is considered a non-metal, as well as all of these that are in green. Even our halogens are considered non-metals. So carbon all the way to fluorine. If you go down to here to AT, it is always hard for me to say that one. And if you go from carbon and it goes down to phosphorus, selenium, no. These that are in purple are what we call metalloids. They can fall into characteristics that are similar to our metals, as well as characteristics that could make them considered a non-metal. We are going to see how this periodic table causes different types of bonding between atoms. So lithium will bond completely different with magnesium than he would to oxygen. That's going to be completely different types of bonding. So let's get started and we can see how this happens. So just like last week, we're going to start off with a few terms to make sure we are acquainted with what we're going to be saying. So we've gone over our essential question. Here we have a metal. Metals, like I said, we on the left side and center part. So left side and center part of our periodic table. So left and center sections of the periodic table. I'm just abbreviating periodic table for PT. So that's periodic table. They are often shiny, malleable, solid, and good conductors of electricity. Sorry, that says electricity. Okay. I'm gonna make this look a little bit nicer so you can see it. Electricity. I still ran out of them. So electricity. So a non-metal is anything that's on the right-hand side of our metals. So from aluminum to gallium to selenium, bismuth, and polonium, everything to the right of those are considered non-metals. So it's the right side of the periodic table. Okay. They are, my brain's like, they are often brittle when they are not in the solid form. They are not shiny. They are very dull kind of look. So if you think of your pencil has graphite in it, which is a carbon. That is very dull looking. But if you were to take aluminum, like aluminum foil from your living room or your kitchen, and you flip it over and you see one side of it's shiny. The other side is purposely made dull for when we cook. But that aluminum foil is shiny on one side. So it's non-metals are not shiny. And do not conduct electricity very easily. So what I mean by that, so if you go to your door, right, and you touch your doorknob, you usually get a little zit every once in a while. That is actually a type of metal in your doorknob. If you were to go touch, say, the tires on your car, you're not going to get that little zip through into your body because there's no conducting of electricity from the tires on your car. Right? So you have metals, which are left side of your periodic table. Then you have your non-metals that go from on the right-hand side of your periodic table. And don't forget about hydrogen. He's lonely up there. So now we're going to go and talk about different types of bonding. We have two different types that we're going to talk about today. We're going to talk about covalent and ionic. Okay, let's start off with covalent. I always find covalent is usually the easiest to understand because actually you've been doing this since we talked about bonding last 9 weeks when we bond two atoms together. We've been doing covalent. You just never heard the word covalent. So covalent is a chemical bond between two atoms. I'm going to switch because that's going to run out of room. That chemical bond that involves the sharing of electrons between two atoms. That's a 2. This is very specific and usually occurs most often. Okay, this is where it's going to, right here. So covalent bonds are most often associated when two two non-metals. So it's two non-metals that bond. So I'm going to put a little star right here. It's specifically two non-metal atoms that bond. So I'm going to get my periodic table real quick. Right. So what I mean by that, you have your hydrogen and you have your left side of your periodic table that are considered nonmetals. These atoms and elements have the same type of behavioral characteristics, okay? So when they bond, they're going to act very much the same. They're not going to be greedy over one or the other. That's just like if, like your parents, they share in household duties every once in a while. They cohabitate and they share. Like, okay, let's rewind. I'm going to do another example real quick. Maybe this will help a little bit more. Your parents, they came together and they had you, right? They shared in the producing of you. So they take the equal amount of contribution to making you. When you bond, say, hydrogen and fluorine, they're going to share equally those electrons between them. Okay, so hydrogen's going to equally share his one valence electron with fluorine. Okay, so it's a sharing. Neither party is greedy or overcompensating to bully the other, should I say. It's going to change when we get to ionic, though. But let's stick to covalent. Covalent is the sharing. Where is my highlighter? So it's the sharing of two. Oh, that was too dark. My bad. Sorry. The sharing of two of electrons. So, for example, when I say it's usually between two non-metals, if we take our oxygen atoms, so say we have oxygen, we're making O2. You take one oxygen atom who has 6 valence electrons, and you take the other oxygen atom, 5, 6, who has 2 or 6 valence electrons. Each one of them have 2 electrons that they can share. These 2 oxygen atoms are the same. Okay, they're the same. They are going to be like, I'm not bigger than you, you're not bigger than me. We are going to share equally these electrons to bond. So we are going to equally share them. We're not going to bully each other. They're just there to help us. And that makes O2. And don't forget about his lone pairs that are not part of bonding. So now we're going to go and look at a compound. But we have, so remember, this is a molecule. Okay, a molecule is any 2 atoms that are bonded together. 2 or more, excuse me, 2 or more atoms. Let's go down and we're going to look at water. Okay, we have hydrogen. Switch my color. We have oxygen, who has 6. Each hydrogen has 1. So this is a compound, and we're going to, it could also be considered a molecule. You can say either one for water. If you look at oxygen and hydrogen, they are both non-metals. So even though oxygen is way over here and his size is bigger than hydrogen, they're going to share their electrons. So hydrogen, use the brown. Hydrogen is going to share his 1 electron with oxygen, and this hydrogen is going to share his 1 electron with oxygen. And this is where we make water. Sorry, I'm trying to get y'all used to the lines. Don't pay attention. I wish I had corrective tape. I'm gonna redo this down here because I'm trying to get y'all used to seeing the bond lines. So remember, a line between, like we discussed last week, the line between two atoms, like this line between hydrogen and oxygen. This just means you have 2 electrons between them. Same thing with this oxygen and this hydrogen. So he has 1, 2, 3, 4, 5, 6, 7, 8 electrons around oxygen. Let's do a couple more examples. We have iodine and bromine. So it makes, we have iodine and bromine bonding together. Iodine has 7. 1, 2, 3, 4, 6, 7. Bromine has 7. All right. Again, real quick, bromine and iodine are both non-metals because they're on the right side of the periodic table. So they are going to share their electrons. They are going to share and make iodine bromine. So again, cover up bromine, we see 2, 4, 6, and then the 8 right here. Okay, cover up iodine, we have 2, 4, 6, 8 electrons around bromine. One more and then we'll move on. Let's do carbon and oxygen to make carbon monoxide. So carbon has 4, 1, 2, 4, and we know oxygen, my pen, has 6. 1, 2, 3, 4, 5, 6. Just like we talked about, this is where covalent comes into play very strongly. Okay, this is where you can see between carbon and oxygen that you can make a double bond completely. I'm going to do this line right here just to separate my paper real quick. Okay, you can see that they can make a double bond. But these two atoms actually make a triple bond. And this is where we have that whole covalent sharing and being a nice buddy comes along. Okay, so we know carbon and oxygen can bond and share 2 electrons right now. But like I said, this is where the whole covalent, they are both non-metals, so they're in the same type of family group. Okay, they're non-metals, so they're going to act very much the same. They're not going to be bullies over one or the other. They're actually going to be very friendly to each other and hand over electrons very easily to share. So when that comes into play, we can see this. Carbon's going to go, yo, dude, I see you still have 2 electrons that are not satisfied. Let's do this, okay? We can take, I'm trying to find a good pen. That's not going to fade in with either one of those colors. Hold on. Hoping this works. Ooh, hot pink. Yeah. So he's going to be like, You see this electron right here that I have? How about we do this? You share this electron, we share these two electrons together. We will share these. These will be shared completely. Now I see you have one left, I have one left. I don't need this one. I don't need this electron right here. This is left over. I don't need it. How about you go ahead and take it? So, because I see you have one that needs to still be buddied up, that is not happy. Go ahead and take it to make so you can be happy now. I am willing to share it and give to you to make you happy. So the whole story is they work together and share the responsibility to be happy. Okay, so where's that purple one I just threw down? So now carbon has 3 in the middle of him. We have our amazing oxygen molecule or atom that's going to be a big old bud and help out carbon. And they share those 6 electrons. But now don't forget that they each have a lone pair. Carbon has this lone pair, and oxygen still has his. And that makes a triple bond. So this is where covalent is. They work together. They're cooperating with each other. Okay. So I'm going to give you a second to write that down. And remember, at any time during the week, if you need anything, message me in Canvas and we can set up a Zoom session for tutorials. Or if need be, we can meet after school. All right, now let's go on to ionic bonding. So ionic bonding, this is where the bulliness comes in, where one atom or one element is going to bully the other and say, I'm taking this electron, you're going to give it to me, no ifs, ands, or buts about it. That's just the story. That's just how your life is I'm bigger, I'm badder, I'm taking it. So for ionic bonding, it is the complete transfer of of electrons between atoms. This will cause two oppositely charged ions to occur. So all an ion is an atom that now has either a positive or a negative charge to it. So this type of bond, an ionic bond, occurs between a metal and non-metal bonding. So I'm going to make an asterisk right here. So it occurs when non-metal and a metal atom bond. And we're going to see that here in just a second. We're going to have a couple of examples. Our first example is sodium chlorine. Okay. So if we look at our periodic table, we can see sodium is a metal. He's on the left side of our periodic table. Chlorine is a non-metal. Okay, so they're on completely opposite ends of the periodic table. They're going to behave very differently. Okay, so we see that here. If we look at, when we see sodium, we know sodium has one valence electron. And we know chlorine has 7. Right? Chlorine is going to be the bully in this relationship and steal sodium's electron. When he takes it, he will become positively charged because now he's given his stuff up. He doesn't owe anybody. He's lost one. So he can give that, he's a positive charge. Chlorine, however, now is negatively charged. And all we do is put a negative sign right there. We imagine the 1 right here. We don't need it. It's a waste of our time to even write it. We know that this is negative because he has an extra electron that he did not start out with. So a relationship that you can think about this is with a bank. Okay? If you don't owe the bank any money, you're in good standing. You're in a positive relationship with your bank. Now, if you go and take out a loan, or if you take money from that bank, you now owe that bank money. You are in debt. You are in a negative standing with your bank. Sodium gave up his electron, so he doesn't owe anybody any money. He's in a good standing because he can go and make a relationship with somebody else without having any baggage. Chlorine, on the other hand, the greedy little jerk that he is now in a negative standing because he's taken money from sodium. Okay? But when we bond these two back together, we make sodium chlorine, which becomes a neutral atom. So a neutral atom is this positive charge and this negative charge connect, and the negative and the positive equals out. That is like you going and getting with somebody that owes the bank some money, and you're the bigger person and you pay off that person's debt. Now y'all are in a neutral relationship and nobody owes anybody any money. Okay? So that is ions. Ionic bonding is when you have positive charged atom, a negatively charged atom. They connect and they make a neutral atom. We're going to do a couple more. If you go to bromine, he has 7 valence electrons. Oh, right? He is neutral. He starts with a 7. That's what he has. Lithium comes along, and the poor buddy has 1 electron. Bromine's going to go over to lithium and beat him up, take his electron. So he's going to take this electron. And now bromine, I hate that color. See if I have where's that other blue? All right, go to this blue. He now has 1, 2, 3, 4, 5, 6, 7, and he has that 1 electron from lithium that makes him negatively charged because he's taken something from lithium. And now lithium, the lovely dude that gave up his stuff, is positively charged. Oh, I just realized I'm out of frame. Sorry. He isn't. So bromine took from lithium, made bromine a negative charge. Lithium is a positive charge. If we bond these two together, you go right back together, we would make bromine lithium. Lithium bromide, excuse me. It's lithium bromide. It's supposed to actually be backwards. I wrote that wrong. Lithium bromide. And now they are a neutral atom because they buddied up again. Positive charge, negative charge, it equals out and becomes neutral. Let me do that. So we have it all in frame. Let's do a couple more. We have calcium chloride. Which is CaCl2. So all this little 2 means is there's 2 atoms of chlorine. So you have calcium, which has 2 valence electrons. 1, 2. You have chlorine. Each chlorine has 7. 4, 5, 6, 7. This chlorine has 7. 3, 4, 5, 2, 4, 5, 6, and 7. Missed one. Yeah. So we see that each chlorine has 7 electrons. Calcium has 2. Each chlorine is going to go beat up the calcium and take his electrons. So chlorine comes over here and takes from calcium. This chlorine is going to come over and take from calcium. So now we have 2 negatively charged chlorine atoms. And because he gave up 2 electrons, calcium now becomes positively charged with 2. Because he gave up both of those electrons, now he's in really good standing. He has a positive 2 for a charge. Each chlorine has a negative, and if we bond them back together again, we get calcium chloride, and it's a neutral atom. Because these negatives are then balanced out with calcium's 2 positive. One more. We're going to see this example again here. We're going to go to NaO2. Na2O. So that's sodium oxide. We have 2 sodium atoms, each with 1 electron. Then we have oxygen, who has 6. 5, 6. This oxygen, because again, oxygen is a non-metal. Sodium is a metal. They're going to bond ionically. But sodium is the bigger dude in this party. Oxygen is the bigger dude in the party. So he is going to go over to sodium and take sodium's electron. He's going to take that one from that sodium. Now we are going to have an oxygen who has now 8 electrons, which is a lot more than what he started with. 2 to be specifically, and he's in debt by 2, so 2 negative. And then each one of our sodiums gave up one, so they are positive charge. Okay, and if you bond them together again, you come up with sodium oxide, which is a neutral atom. Okay, so again, ionic bonding is the bonding between a nonmetal and a metal atom. When they break up, that the non-metal atom is going to take that electron from the metal, and that's when we get our charges. Covalent bonding is the equal sharing. It's going to take a lot to break them up. Okay? They're going to equally share the responsibility to make each other happy. So now let's go and finish. An ion. We've been talking about an ion the whole time. Okay? An ion is just an atom or a molecule with a net charge. So they've either gained or lost electrons. So it can either be, they can be positive, and if they are positive, that means they've given up an electron, or negative, which means they take an electron. So some examples of just an ion, how an ion looks. We have sodium, which is a positive. We have oxygen, which would be negative because he would have 8 electrons instead of 6. You have lithium, which would be positive because he gave up his electron. And then you have phosphate, which would be PO4, which would be a -3. Okay, because when you're bonding phosphorus to 4 oxygens, 3 of those oxygens take electrons. Okay. Chlorine is a negative because he takes electrons, which would give him 8. Oh, a lot more than what he started with. He starts with 7 and he comes out with 8. And then you have HSO4, which comes from a strong acid, which would be a negative. All right, so the original molecule for HSO4 is H2SO4. They kick a hydrogen out of the party and take his electron. That's how they wind up with 1 extra. We will learn that more later as we get through our bonding section. All right, now we're going to go and specifically talk about different ions. We have anion. So an, ion, an, ion, anion, which is a negatively charged ion. Negatively charged ion on a molecule or atom. So some examples are, you have oxygen, which would have 8 electrons instead of 6, which would be a -2. You have bromine, who would start out with 7, ends up with 8, and has 1 negative. Hydroxide, which is OH. Originally, they started with a hydrogen on there. They kicked the hydrogen out of the party. and they wind up with a negative because he winds up with 8. Oxygen winds up with 8 around him, so he winds up negative. Then you have, I'm trying to write out the whole word. I don't want the whole word. Phosphates, PO4, -3. All right, real quick. Sometimes I would write the negative in front or in back of the number. As of right now, it really does not matter which way. When you get into general chemistry for your junior, Coach Gates, or whoever your teacher is may tell you differently. As of right now, it's not going to matter which way it looks. Then you have Cn negative, which is cyanide. They kick a hydrogen out of the party and they keep his electron. Yep, SO3, 2 negative. They kick, this should have been H2SO3. They kick 2 hydrogens out of the party. They keep the hydrogen's electrons and they become negative because they've taken something. Right. Now we're going to move on to my favorite way of saying this, cation. Cation. So if you think cation, a cat has positive, okay? So a cat ion is positively charged. So cation is a positively charged ion on a molecule or compound. Yep, almost misspelled it. Molecule or compound. So some examples for this is our lovely sodium ion, who generously gives up his electron. We have lithium, who gives his up. We have calcium, who started out with 2 and gave up all 2 of his electrons, so he becomes 2 positive, or positive 2 for his charge. You have ammonia, which is NH4. He is positive charged. This specifically the nitrogen would be positively charged because he gives up one of his electrons. You have barium, which is 2 positive, and aluminum ion, or atom, excuse me. Aluminum is an atom, barium is an atom, calcium is an atom, lithium is an atom, sodium is an atom. Ammonia, NH4 plus, is a compound or a molecule. So remember, these are atoms because they're by themselves, they're not bonded to anything. Ammonia is a molecule or a compound because it's 2 or more atoms that are bonded together. All right, so we go up and let's do some practice on breaking bonds, and you can see our ions form. So here we're starting with sodium and chlorine, or sodium chloride. So if we have them already bonded. This is the table salt that you get off your kitchen counter. If we go ahead and we break their bond that's between them, we form sodium cation, so sodium positive charge. And I'm going to draw a little positive because when we draw a positive between 2 atoms, that means we have those 2. So sodium, which is a cation, a positively charged ion, and chlorine, who has taken sodium's electron and has become negatively charged. I'm going to draw out the Lewis dot structure for the next one for both of them. Now we're going to go to lithium fluoride. I'm going to draw them both out here. So you have lithium, which comes into the relationship. He's bonded to fluorine. So they're bonded. And fluorine already has his electrons that are going around. Okay, so when we break them up from their bond, fluorine is going to go to lithium and take his electron and take it for himself and kick lithium to the curb. Okay, when he kicks him to the curb, lithium becomes a positively charged ion. Okay, he's positively charged. He's a cation. Fluorine becomes an anion, which is he's negatively charged because he's taken sodium's electron. Let's go to sodium oxide. We have one sodium, which is sharing a bond with oxygen. And we have that other sodium. Ah, sorry, that's supposed to be sodium, not an oxygen. Whoops, there we go. Okay, so here's sodium's electron on that one for your right-hand side, and here's this one for your left-hand side. Now, when we go to break this relationship up, oxygen is going to take this electron, and I forgot to draw his other 2, 4, 5, 6, 7, 8. Yeah, that's right. So he's going to take this electron right here. He's going to take this one and keep it for himself. He's going to give sodium the boot. He's going to take this one for himself and give sodium the boot. We come on and we go to our right-hand side. This is our product. We have 2 sodium ions, cations to be specific. So 2 of those. This can be, instead of doing 2 like this, oh, I'm so sorry, I did not realize I was out of frame. I am incredibly sorry. Instead of wasting time and writing both sodium ions like that, you know me, I'm efficient with my time. I'm not going to do more than what I absolutely need to. So when we have 2, we can just do this right here. 2 sodium ions. That means it's 2 sodium cations. Then we have 1 oxygen anion. So the number in front is just a coefficient. Okay, you're going to learn that word next week. Coefficient, meaning there's 2 of something. Okay, it's just a big number in front of an atom or a molecule to say there's 2 of them. This one right here up top is just saying there's 2 electrons extra on that oxygen. And that is our covalent and ionic bond. So again, covalent is between 2 nonmetals bonding, and they share equally electrons. Ionic bonding is when a nonmetal and a metal bond and they do not equally share those electrons. One is going to be the bully and take it, while the other one's just going to be the big baby and just lay there and give it up. And then you can make different types of ions, positive or negative. A negative charge is an anion. A cation is positive. They have positive. And when you break up an ionic bond, you can make different charged atoms. Okay, so that is it. If you have any questions, let me go back here. So if you have any questions following this, please reach out and message me in Canvas or stay for tutorials. If you have to do it, we can do Zoom or we can do face-to-face tutorials. So until next time, see you later.